Now we're recording.
Thank you everyone for your patience. As all of us are learning, we're still advancing our technology work, and we appreciate patience with it as we work through those kinks. So thank you very much for joining us today, both in person and on Zoom, as we join you here from the homeland of the Penobscot Nation. This is the third of a program in our new and exciting Decades of Collections program series here at the Wilson Museum that is being generously supported by the folks at Bangor Savings Bank, and will continue throughout the course of the year. We'll take a bit of a pause in summertime as we gear up our summer activities, and then we'll be continuing through the fall. The next program in this series, I believe, is June 7th, where Genevieve Lemoyne from the Peruvian Arctic Museum will be speaking about Inuit communities adapting to a changing Arctic, which is the second of the four themes that we're addressing through this program series. Dr. Sandweiss will be speaking about shells and how we can learn about changing climate and ocean health from shells. The other program series themes we're addressing this year are using pottery as a way to look at culture, and starlight, and how cultures across time and across the world connect to the stars and are guided by the stars. We're excited to welcome you here today, and I'm going to pass it off to Haley, who will introduce our speaker, and then we'll make sure we have some time for questions at the end.
Thank you.
All right, hello everybody. My name is Haley Blake. I'm the education coordinator here at the Wilson Museum, and I want to go over a few housekeeping things for you all before we get into our presentation. One is that we have for the in-person audience, we have the doors open as an emergency exit in case we need to leave. We also have bathrooms through the kitchen on the other side of the kitchen. And as Julie mentioned, we have a live in-person audience, which is all of you, and we have a virtual audience joining us also. So we might take questions from the audience and we'll take questions from you. We're happy to have you. So now I'll introduce our speaker. Dr. Sandweiss is an archaeologist interested in maritime adaptations and climate change in Latin America. Most of his research has been carried out on the desert coast of Peru, but he has also worked in Central America, Honduras and Guatemala, and in Cuba. In Peru, he worked on early preceramic sites studying climate change and its effect on people. This focus has led to an interest in prehistory of El Nino, a global climate perturbation first recognized in Peru and now known to affect weather throughout the world. He continues to evaluate the hypothesis that the North Peruvian coast experienced major climate changes involving El Nino frequency about 5,800 and 2,900 years ago. Shells from archaeological sites play a critical role in these studies. At the University of Maine, Dr. Sandweiss is a professor of anthropology, quaternary and climate studies, and global policy. All right, that's a lot of words that I don't normally say on a daily basis.
Most people don't.
So thank you. Please help me welcoming Dr. Sandweiss.
Hey, everybody. So I will, so that you can hear me, I'll take this off. All right, well, it's a pleasure to be here. What a beautiful day. Thanks for putting on the good weather. Appreciate that.
Yeah.
It's a nice drive down from Orono. So I'm going to talk to you about shells. The question, what can shells tell us? They can tell us actually a ton of different things, and I'm not going to tell you all the things that they could tell us because we wouldn't get out of here and be really boring. So I'm going to focus on two main things. I'm going to talk about shells and climate, and if time permits, I'll talk about shells, symbolism, and climate, and all of these in the context of ancient Peru, where I do my research. In fact, I started working on shells when I was an undergraduate. I realized that I wanted to do archaeology, and we're doing a digging course in the harbor next to the university where I was. And there wasn't much. It was a historic site from the early 20th century. It didn't have much, but one of the things it had was a lot of quahog shells, hard shell clams. And so I did a tutorial the next semester to study what we found, and mainly that was the shells. So I started to get really interested in them, worked on them. One of the things I wanted to do was to figure out how much meat they had contained, so that if you got ancient shells, you got some idea what contribution they made to the diet. Well, that's not what I'm going to be talking about today, but it is one of the things that you can do. So to do that, I went with my advisor. We bought 100 live Mercenaria quahogs, took them back to the archaeology building. I took all the meat out, I weighed the meat, and then I needed to dry the shells because when you dig them up, they're dry. So I was going to go off for the summer to go to Guatemala on my first field trip. So I put them, they had one of those, it was an old house where archaeology was, and they had one of those cellar doors that goes up and opens like this, the big wooden door. I said, oh, that's a good place. I'll just put these shells in here to dry. Well, of course, you can't get all the meat out of them. And when they dry, they don't smell really good. And nobody, they knew that something was wrong in the building. They didn't know what. When I came back and they found out it was my show, they weren't really happy about that. But, you know, this is what research is about. You have to make do with these things. Anyway, so I started going to Peru and I kept working on shells there. And although I do many other things, shells are still core to a lot of what I do. And I'm going to tell you something about that. So if we're going to do that, we talk about ancient Peru, we should look at the environment we're going to be working in. So this is the coast of Peru. Oh, this is far north. Just for context, that white stuff is not snow, is not Maine. So this is the map of Peru. You can see that nice Pacific coast. The entire country is within the tropics. And in fact, the equator cuts across the northernmost part of Peru and the Amazonian jungle. But the tropics sort of end right about here in Chile. So it's entirely tropical country. You might expect, if you haven't been there, that that's what the coast looks like a Caribbean tropical island. Not true. It looks like this, and that too is not snow, that's sand. It is one of the world's driest deserts in most years. There is an exception that we're going to see. And then between the river valleys, this is what it looks like, just bare hills and sand. Just to give you an idea of how much, this is a single dune. These are 3 pictures of the same dune. There's an air photograph of it from the 40s. There was a picture I took around 1990. And then in this one, I'm standing down here at the base looking up. This person was 6 feet tall. His name was Tor Heyerdahl. He was the guy who sailed the Kon-Tiki. For those who may have, a few of you may have heard of the Kon-Tiki. He used to be very famous. But that was him, and he was a tall guy. And you can see how big that dune actually is. And that's just one of them. So very dry. You might wonder then why people live there and how you could actually have major prehistoric and modern civilizations there. And the reason is twofold. One is that the ocean off the coast of Peru is cold Antarctic water. This is partly why it's a desert. The cold water cools the air that comes across so that when it goes over the land and warms, it doesn't precipitate. But it also means that there's a lot of upwelled nutrients, and it's one of the world's greatest fisheries. So not only are there lots of different kinds of mollusks in great abundance, there are also lots of different kinds of fish and sea mammals and seabirds, lots of things that people can extract and eat. The other is that although it is a desert, there is water in the river valleys because the adjacent Andes Mountains do receive rainfall. That's the other half of it being a desert. They create a rain shadow. So it rains in the Andes, and then some of the water comes down to the Pacific in rivers. And if you can draw water out in canals, irrigate, then you can grow crops all year round because it never gets below about 59 degrees Fahrenheit. In the worst of the winter, everybody thinks they're going to die from that cold. It's damp and chilly and there's no heating, which is true. It's not comfortable, but it's still growing water all the time. So you can see what a typical irrigated valley looks like. Green, as far as you can irrigate, and then in the other end, you get above the canals and you're back into that stark desert. Just to show, there have been sites in Peru for a very long time, at least 13,000, maybe 15,000 years. So we have a lot of archaeological sites to provide records of many things of people and their behavior, of course, which is, as archaeologists, what we're principally interested in. But there's also a lot of information about climate that comes from the things we find in these sites, including the shells. And this is just another, so this is a very late site. This was occupied up until the time of the Spanish conquest. It's a site called Tucumay. This is where I actually worked with Tor Heyerdahl for a number of years, right after I got my doctorate. It's an amazing site. You can see all those big mounds, which are the Peruvian equivalent of pyramids. They're not burial pyramids. They have rooms on top for elite people. It's a different purpose, but they are built in the sense of being very tall, steep-sided. I'll just give you an idea of some of the context in which we find shells and to show you how abundant they can be. These are typical excavations along the coast. These all have the two on the let's see, this one, let's start here. This is the oldest. This goes back to almost 13,000 years. This one is about 6,500 years old, and that's at the bottom is about 11,000. The top's about 5,000 years ago. So you can see shells preserved very well. All things preserve better here than most places because it's a dry desert. If you go this far back in time, before 5,000 or 6,000 years ago, not everything preserves equally well, but the shells last really nicely, and they create a good environment for other organic, other once living things to be preserved. It's like in Maine, the only place you find bones that aren't charred or almost anything else that used to be living in Maine is in the coast in the shell middens, because the soils are so acidic that without the shells to neutralize them, things would disappear. So there's something that shells do for archaeology. They create good preservation environments. So we're going to talk first about shells and climate, and very briefly talk about this because it's really a story about El Nino. I'll just tell you a little about what El Nino is. It means the child in Spanish. It's named for the Christ child because it was first observed as an annual warming that happens in the farthest northern part of Peru and the southern part of Ecuador at the beginning of the austral summer, which is right around Christmas time. It goes from December 21st to March 21st. That's the austral summer. So they noticed, fishermen noticed that it would warm up every year about that time, starting at Christmas. So they called it El Nino. And then later, it was applied to this phenomenon that occurs irregularly and at much longer intervals, depending on how the really strong events might only be, once a decade or even less currently. Smaller events could be every 3 to 7 or 8 years, but it's not every year like what they originally named it for. And what happens is that the water is normally cold, but during El Nino it warms up. So the redder you get, the warmer it is. Here's the coast of Peru, and you can see what happens in El Nino events. It gets, this is warmer than normal. So the redder, that's really a lot warmer. When that happens, a bunch of things go on. One is that there's much less nutrient upwelling, so you have a smaller biomass in the ocean. The other is that it allows convective storms to occur on the coast. It's the only time it rains. So it's horrible desert. Well, it's a beautiful desert, but it's a very dry desert most of the time. But when El Nino comes, one of the big events, then there's torrential rainfall. And that's not really a good thing if you live in a desert because you're not set up for it. There's no vegetation to hold the soil or the rubble in place. Everything gets eroded. A lot of destruction, a lot of diseases from the standing water. You would think that rainfall would be a blessing, and it's not in this environment. It's a nasty thing. So that's why we're interested as archaeologists. What did this nasty occurrence do to people in the past? When did it occur? How often did it occur at different times in the past? So we try to identify El Nino events from archaeological remains. It's one of the many ways. You can look at other kinds of data. You can look at ice cores to get climate data, very high resolution. You can look at lake cores, sediments that accumulate through time in lakes. You can look at corals and get high resolution, but fairly short floating periods. You can more or less date. So you can get better resolution than you can from looking at things in archaeological sites. But the ice in the Andes is on the eastern side of the Andes Mountains, where it's affected at least as much by climate off the Atlantic as from the Pacific. So it's not a perfect reflection of what's happening in the Pacific, where El Nino is centered. It's a desert, so what lakes are you going to get? Oh, it turns out there's one lake that occasionally forms during El Nino, but that's a rare thing. Normally, it doesn't have deep sequences and sediments. And then corals, it's cold water, so you don't get corals there either. So the shells have turned out to, and the other things we find, but starting with the shells, it turned out to be really important in putting together the story of El Nino's behavior from the time people arrived until the present, or until the historical records. We started doing this really with shells. So it occurred to us that these events must cause a change in the way the shells grow, because most of the species, the mollusks, die during these events, but a few survive. We thought, well, let's see what these events do. So we had this wonderful for us and really terrible for other people who lived there, natural experiment in 1982-83, in which a very powerful El Nino came and hit the coast. And most shells died. But this is one of the species that survives. So we got some money from National Geographic. This was when I was in grad school. And I collected shells that had survived the event. And then with my colleagues, we studied them. We looked at how, you can see sort of growth rate you can actually see here. We could see microscopic changes. Basically, we found out how to see El Nino in shells to give us a tool to look at individual events in the past. And you can also look at the isotopes. It's their chemical elements. Two of importance here. So this is a sequence from a shell that lived through the 82-83 event. This is the event here. It should say 82-83. Sorry, that's slightly. But what happened is So this is the carbon-14, which is the radioactive isotope of carbon. That's what you get dates from. Normally, there isn't as much as there should be because it's old water that's upwelling, so it's depleted in carbon-14. But during the El Nino event, the upwelling goes down, and so it comes up to be in equilibrium with the atmosphere, which is unusual. This is oxygen, and a dip here means it's getting warmer. So the things it worked really beautifully. We know how to see these events in individual shells, not only in the way they grow, but we can confirm them and see how strong they were by looking at the chemical composition. What we also found was that there was a big change in which species show up in sites when. I discovered this pretty much by accident in 1980 when I was just beginning my graduate school career. I was spending a year in Peru, and one of my senior colleagues had sent me to look at some beach ridges along the coast. And when I was there, I happened to run into an archaeologist who worked in the area. He said, "Oh, you're interested in this early stuff. There are these early sites on this old beach. Oh, if you want to go look at them, that's fine. I don't care. Here's where they are." We went out and they had all these weird shells that didn't look like the ones I knew from all the normal Peruvian sites. Now, this is what the principal shells were. These are not what you get on the coast of Peru today. You have to go up into Ecuador to find these. So we knew something had been very different. This is the ancient beach that the sites were associated with. All that dark stuff here used to be 6,000 years ago underwater. The coast has since receded, but this is where these shells were living. We actually found some of them still in living position. You see they're what we call articulated. They're still together. This is where they died. So it wasn't that people were bringing shells all the way down from Ecuador, which would have been bizarre to say the least, but you couldn't eliminate that, except that we found that they actually were living here in natural conditions. So they reflected the climate, which was warmer than the climate is there today. So we decided that this probably meant the El Nino system we know now couldn't have been operating at the time these shells were here. We started finding the similar ones when other sites of this age, from about 8,000 to about 5,800 years ago, El Nino was pretty much absent or very different from today. So we got that first from shells. We've confirmed it in a variety of ways. We've looked at the fish. We've looked at the records around the Pacific Basin from natural kinds of archives. And it all shows a decrease in the kind of variability that happens every so many years, which is what El Nino is during this time period. We were also interested in like when that ended and what happened, when did things become what they are today with cold water and cold water shells. So we looked at sites on this other ancient embankment. So the last site we're looking at would be about 20 kilometers that way. This is another one of these former beaches where the coast has now moved to the west. This is one of the sites. This is a very cool site that one of my former grad students has been working at for 10 years now. Among other things, she found the first adobes used to make buildings in the New World that date back to about at least 5,400 years ago, just after El Nino came back, and they were made out of sediments that were created by the rainfall. And then instead of puddling mud together with sand or straw or something else that they do now and have for the last 4,000 and some years, they just cut out these blocks of mud and they made walls out of them. I didn't put up pictures, but it's very cool stuff. That's a digression, but I went here first in 1980 to look at sites that had normal cold water shellfish, like the ones you see here. This is what you would find mostly along the coast of Peru today, including this north coast area. These are a different set of species. This one looks like one of the others, but it's a different species of scallop. There's a warm water one and a cold water one. This is the cold water one. The other one was the warm water one. Fortunately for us, to help us make the case, some geophysicists from Canada had gone to that same dry beach that I just showed you and collected lots of shells from different, mostly natural places and dated them through radiocarbon dating. So we lined them up. From what we've seen in archaeological sites, the change was at 5,800 years ago. Anything that's red can only live when it's warmer than today. It can't tolerate the cold water. Anything that's blue can't tolerate the warm water. And the green ones can live in both. And there's the difference, 5,800. So this was actually very strong support for what we were saying. But the story kept going. We kept looking more. We realized that there were two species of shells that were really important from this change at 5,800 years ago until about 2,900 years ago. This is one of them. It's a mussel, like we get mussels here, right? But these are bigger. These can get, I've actually seen a few paleontological ones about this big. But frequently they're like this. You could get a meal out of one of these things. And they seem to have been very popular as food, and we'll see later for other things as well. They're very colorful. The darker part is actually bright purple. I think I have some color photos coming up later on. But this one, we know, doesn't survive warm water at all. They're still a commercial species in Chile. They're not in Peru now, and they haven't been for a while. And they haven't been up in this north coast area since 2,900 years ago. But in Chile, they're commercial. So a German marine biologist was trying to figure out the temperature tolerances of several commercial species. This was one of them. So he did experiments where these things aren't sentient, right? I mean, mussels, snaps, they probably don't feel pain. But he basically kept raising the temperature on them, sort of like the frog in the pot, right? You go up and found out what's called, and they massive numbers. They found something called the LT50. That's the lethal temperature at which 50% of a population dies in 24 hours. And the LT50 for these is 28 degrees centigrade, which is what the big El Nino events get to for weeks on end. So these would all be dead within a week when one of those El Ninos occurred. And if the events were infrequent, then they would be able to slowly work their way back up as the larvae go north. Usually the currents go the wrong way, so it takes a while to replace, and they would come back. And that seems to have been happening from 5,800 to 2,900 years ago, when we know El Nino was back, but we think it was infrequent. After 2,900 years ago, they disappeared in the north coast. It became much more frequent, and they couldn't make it back. This is another important species. Where present, it's what people prefer to eat. It's called Mesodesmodonaceum, or the popular term is matcha. They're really tasty. You can also dry them, and they preserve really well. So they're lightweight, high protein. You can trade them. They traded them even in the colonial period. They were trading them up into the mountains. They also have iodine, so they're good for a lot of reasons. So these are another important one. They too cannot survive El Nino's heat, and if it's very frequent, they can't work their way back. We know that they used to be present to Lima, which is 12 degrees south, before 1982-83, because it had been 50 years since a major event. They were knocked back 400 kilometers by that event. Another event came in 97, 98, 15 years later. They hadn't recovered any of the territory in that time, and then they were knocked back all the way to the border with Chile, and they're still not fishable in quantities in Peru anymore. They used to be a major fisher when I started going down. So the kind of sites we found them are very interesting. When El Nino starts at low frequency, we start to get people building mounds. Not the very first, but among the first. And this is one of the little ones, an early one. A slightly bigger, this one's been reconstructed, but that's what it would have looked like. It's a site with 6 mounds. This was the smallest. Through time, then they got pottery about 3,600 years ago, 1600 BC. So these are actually the two parts of the same site. This is one part. This is the other. If you drew a line through they're bilateral symmetrical. So this happens in mirror. The line basically bisects them. This is bilateral symmetrical. So that's 2 kilometers across. It's a lot of site planning to be able to make something that big, 2 kilometers with that careful planning. But they're still getting these shells that don't like El Nino. This is outside the airport in Lima. This mound was so big that in the 50s, they thought it was just a hill, and they put a power tower on top of it. But in the 70s, when archaeologists dug, they found things like this artwork inside of it. So unfortunately, they put the power tower on it. And then after 2,900 years ago, those two species disappear from the sites in the north coast, and they're replaced by this little surf clown called a donax. And you find just thousands, millions of these things. The sites are chock full, but you don't get those ones that can't survive the warm water. These, because they live in the surf zone, they're well adapted to changing climate. They are hit by El Nino, but they return quickly. They're never gone for very long. Same with a couple of little mussels as well that could survive because they live in the intertidal zone. They were adapted to these changes. So we see this wholesale change in shells. That's what really told us that there was a big climate change that had to do with El Nino. We got it from the shells. We've been tracking it in other ways since then, but the shells gave us the entire clue. The first paper that we published on this about the change 5,800 years ago, my colleague who was leading that research at the time, professor at the University of Pittsburgh, who studied mollusks and their paleontology of ancient mollusks, was left-handed and a punter. I'm a punter, or you probably can't tell, I'm very careful today. But he was much worse than I am. So he called this paper the Birth of El Nino. And El Nino, of course, is the child. Because that's when you think it started back up. Interestingly, when El Nino becomes much more frequent, they stopped building those temples for hundreds of years. They didn't like lose their population. They still had complex sites, but they didn't build the same kind of mounds. They built very different sorts of sites. And it looks like this change to a much more frequent devastation from these events led to perhaps a crisis of faith in the religious system that was behind these mounds, and people didn't support them anymore. All right, how are we doing on time? I'll keep going.
So,
Yeah, 15 minutes. You just tell me to stop when I'm going on for too long. I will be questions.
okay.
But I want to talk about this, one of these shells, Tromidalus, and another one we haven't seen yet, Spondylus. Anybody heard of Spondylus shell? You have some over here, I believe. Yeah, they're super colorful, red, spiky. I'll show you a picture in a minute. So there's a color picture of the Tromidalus. These are old ones, but you see that purple color. It can get even brighter than that. Really, of the shells that are native to the cold water, this is the most colorful one along the coast of Peru. And then you get these, which come down from Ecuador. They do not grow normally on the coast of Peru. They grow in Ecuador in warm water. And this is a genus Spondylidae, which was important in the Mediterranean. It was important in the far Pacific, and it was important in the New World as a shell symbol. It clearly caught people's attention. The color, the shape, the spikiness, important. So Spondylus is well known. We know a lot about it because they were still using it when the Spaniards arrived. There's actually discussion for how much a piece of it would be worth in Spanish money because it was so important to the natives as an offering, as a symbol. We'll talk about that. And it shows up in images for thousands of years, at least 3,000 years. And so there's some pots that are representing Spondylus. Here's an individual actually holding one. There are complex images of people diving for them, presumably in Ecuador. Oh, I didn't find it, but so it was. What do we know? We know a lot of that should say the known shell. Well, that's the version in Spanish. We know a lot because the Spaniards recorded things about it. So we know that it was an important offering to assure that you would have fresh water, that there would be sufficient water for agriculture. And in the desert coast, particularly, that's important, but it was important in the highlands where rainfall drove the agriculture, and they also needed to be sure they had water. It was also offered for other things, which you can see here: health, agricultural fertility, given as dedicatory offerings, put in burials, but generally in the burials of people with power. And that's more than you need to read, but that's a description of some of the things that could be done with this that we know about from the early Spanish documents. It was also considered as food of the gods. We have one fairly complete set of beliefs, stories about gods and so on from the Spaniards. The Spanish in the early 1600s were running something called the Campaign for the Extirpation of Idolatries. They figured out that native people were hiding their religion behind Spanish symbolism and were continuing to worship their gods, and they realized they were bad to try to get rid of it. Smart though, they realized that they could only recognize it if they learned about it. They could only get rid of it if they knew about it. So they had people going, basically anthropologists, ethnographers, recording these. One priest who became bilingual in Quechua, the native language for much of Peru, wrote them down in Spanish and in Quechua, and that survived and it's been translated. So we know because he talks about one of the major gods actually demanding the Spondylus and then eating it. And that's the sound he made when he was eating it. They were traded, as I guess I mentioned before, long distance from the Ecuadorian coast into Peru. We think often they came down by sea. Later, under the Inca, they also traveled inland, along inland routes by land. But sea transport was much more efficient. They had big balsa rafts and rafts made out of bundled reeds as well. And we know that they were efficient. People made these vessels as we produced them. Iredall's done that. That was what Contiki was, a balsa raft. They were still using balsa rafts into the mid 20th century, and there are photographs of them, big ones, carrying cargo, so basically smuggling between Peru and Ecuador. So they could transport a lot. You have to remember they had no draft animals. The biggest animal was a llama, who carried maybe 40 pounds, 44 pounds. And it was going through the desert. Most of what it could carry was fodder, so they couldn't carry much cargo. And you had people who carried a lot, but still much more limited, much not as efficient as going by sea. Then we come to Choromitolis, which was not really well known, but turns out to have been important, particularly early on. So we find painted shells where they painted in the inside. Perhaps they were being used as recipients for paint used for other things, but it looks like they were painted for some other reason as well. We find them worked into different things, different non-functional objects, things that had religious or intellectual functions. We find those fragments. This is Chavín de Huántar is an early religious site from about 1000, basically the first millennium BC. Very important site in the highlands. It spread a religious system throughout much of what's now Peru in the mid first millennium BC. And it was the first time that a single style spread throughout much of that area. So we found them there. Or archaeologists did. They got almost whole shells. Oh yeah, I got the chance to analyze these with my wife 30 some years ago at that site, along with spondylus shells as well. So at that point, they're sort of transitioning and doing both. And their fragments, okay. And then they're found in burials all over the place, but mostly early sites. This is a really early case from a site on the south coast of Peru that this would date to about 7,000 years ago. Those are two sets complete. They were still articulated, so they weren't something that had been eaten. And they're buried under a rock with red paint on it, so which is an important color. So they seem to have been buried as an offering. So that's the ring site. So these are various places where they were offered. It was also, they were really good for making fish hooks. They would take the thick part of the rim and cut them into kind of circular fish hook, which was an important early fish hook type 4, 5, 6, 7,000 years ago. So what role did they play? Well, they were certainly important to eat. They had a lot of meat in them, and we find them in abundant quantities in some sites indicating they were being eaten. But we also find them in contexts that say they were doing something other than eating with them. We know that spondylus had power as an exotic element that came from afar. The harder it is to get something, the more it's worth. That seems to have been true in prehistoric times as well as today. And in the highlands and in the north coast, after about 900 BCE, so 2,900 years ago, it was also an exotic element because no shell grows in the mountains. And the last time that this shell, this purple mussel, had an importance similar to spondylus was between about 1,000 and 800 BCE at Chavín de Huántar, where I said they found them together, big whole shells together as offerings. And then after that, El Nino, that's when El Nino started to be more frequent. It's when those shells disappeared from the north coast, the purple mussels, and spondylus became the shell of preference for people who had power to acquire them. So why would spondylus be more powerful? They could have traded it from southern Peru, right? The Choromitolis, I mean, that's no further away than the coast of Ecuador. So why? Well, one thing we know is that there are reports of spondylus appearing live on the Peruvian coast after these El Nino events. The warm water comes down. In the big events, it can last for a year and a half. The larvae are mobile in the water, and the water is actually moving to the south from where they come. So they could have been implanted and lived there for one generation, but not reproduce. They can live longer under cooler conditions than they can reproduce. El Nino, as we know, brings strong rains and kills the normal cold water mollusks, so spondylus can appear shortly thereafter. So it would have seemed like a dominant, more powerful shell. It could vanquish the other ones, and it could bring rain, be associated with rain, which is so important. Water was important. And we know it's associated, spondylus, with fresh water. So it would appear as a more powerful shell and was preferred by the elites who could get it. Interestingly, we still find Choromitolis in burials, but only with poor people. So when we had a stronger class structure in the societies beginning about 3,000 years ago, and when you have this dominance of one over the other because of the event, what happens with El Nino, spondylus becomes the preferential shell for elites, and Choromitolis continues as an offering for poor people. So there's one of those Choromitolis. There's a spondylus. It's not even a quarter of, and that's the end of the story. Thank you. to hear about shells. I'm sure.
I heard some shells for like an hour and a half last show.
Ah,
Three people, so.
oh, good. Well, I came in under half. That's good. I hope you're not shell shocked. I'd get one in there. So if you have any questions, I would be happy to answer them. Well, I would be happy to try to answer them.
Is there an event like El Nino similar in North America?
No. Well, yes and no. El Nino actually affects the West Coast.
That's what I
goes-
meant, the West, yeah.
Yes, it does. In the 1982-83 event, where you remember particularly the southern part, like Baja California and Southern California is very dry.
Mhm.
So it rains often during El Nino events. And when having a drought, that can be partly good, but in 82-83, maybe you could call this social justice, but it was washing houses off the hills in Malibu down to destroying them. A lot of people thought that was really cool, unless you owned one of those houses, in which case it was
And
not.
this was part of the El Nino that's in Peru?
The same one.
The same one?
It affects the entire Pacific basin with what we call teleconnections. So it also causes changes elsewhere. We're actually benefited by these events because a strong El Nino event in the Pacific tends to be associated with warmer winters in the northeast of the US and Canada. So it reduces our heating bill. Oh, it's not a bad thing for us. Also, because of the way it moves around wind patterns and changes the jet stream, there are fewer hurricanes during El Nino events in the Caribbean basin. Because it basically, the jet stream comes down and shears off the tops of potentially developing storms, hurricanes, and so it reduces their number. And their
And has
intensity.
climate change increased around the El Nino? Or
It is
decreased?
predicted to increase it. So they run a lot of climate models, which are getting better and better. They're, not 100%, but they mostly predict an increase in events, as the world warms.
Now, how frequently do they come?
There's some kind of event every 3 to 7 years. The last really strong event was 2017. Before that, there was a strong event in the Pacific that wasn't strong in Peru in 2015 to 16, followed by this weird one in 17 that was only on the north coast of Peru, but it was really, really devastating, very strong. Before that, 97, 98, 82, 83. So and then before that, 1925. So it's been picking up some. The other thing is that we've now learned that there are all different kinds of El Nino. There's this kind we've been talking about that warms up the eastern side of the Pacific, causes all the rain and all these other disruptions. There's another one where it gets cooler than normal. That's not as disruptive, but it does lead to more respiratory diseases in Peru by getting a cooler climate with more humidity in the air. Then there's another one where it warms up in the middle of the Pacific, like a regular El Nino starts, but instead normally it propagates to the east, to the Americas, during this other kind, which has got several names, one of which is Modoki. The Japanese first recognized it, their meteorological institute in the mid-2000s. They call it Modoki because apparently that means sort of ish or the same but different. And so it starts the same, but then it's different. But it does affect other parts of the world. It just doesn't do it by warming up the water. It changes the atmospheric patterns. So during these Modoki events, the highlands of Peru, for instance, get much less rainfall than normal. And that's, of course, not good because they depend on it for highland agriculture and for coastal agriculture via the rivers that bring the excess water down to the coast. So that's a serious problem that it can actually cut on average like 50% of rainfall, at least as is experienced on the coast as discharge from the rivers. So my son actually found this out while he started doing work on El Nino and this Modoki event on the coast of Peru as a high school student at Bangor High School, where they had just started their STEM academy. And he had a mentor who was a hydrologist at the university. And so he came with me with his high school advisor, and he was looking at, we got records of discharge since 1911 up until I think that was 2013. So over 100 years of records, and he was able to look at the Modoki years and see what that did compared to normal years, and it really cut down the amount of discharge. And then later studies show that in fact it really does decrease rainfall in highlands. So and then there are apparently other ones, but those are the major ones that affect the coast of Peru, one way or the other, noticeably. So as these things get more common, they're not they're not 100% bad. We've been learning the ways that people were able to mitigate some of the problems, but overall, if you're in Peru, it's much more negative than positive. And they're going to get swamped a lot more. Probably. Good question. Thank you.
Guess I'm curious about a little bit more about, what are there lessons that we can learn from the way that the folks on the coast of Peru adapted to this destructive climate events that we can learn from or benefit from as we see increasingly destructive coastal events as a result of the warming Gulf of Maine and climate change?
In a general sense, yes. And this is something that's actually quite new. There was one archaeologist said, you're not paying attention to resilience 20 years ago. And we didn't for a while. And now people are paying attention to it, trying to figure out how people were adapting and mitigating. And the most interesting study has to do with one of the North Coast valleys where the people, as El Nino had become more frequent, started to create special fields that could only be used when there was runoff water from El Nino to partially replace basically, when you get a big event, you lose your main irrigation systems. We know that both from the geomorphology and studying what happens to the land, but also from what happened early in the Spanish colony. So you can have a year or two when you can't grow anything, except if you make these special fields that are set up to channel water differently from different sources, from the rainfall as opposed to from the rivers. They're higher up on the slopes where you couldn't get water from the river, but you can get water when it rains. But it's a lot of investment for something that happens somewhat infrequently. So I think the lesson is you've got to invest in mitigation if you want to survive these things. You can't wait till they happen. You have to actually make infrastructure that will prepare you for them in advance. And they're talking about putting a gate on New York Harbor, right? And things like that. There are a lot of ideas for mitigation, but not many are being done. If we don't do those kinds of things, like sea level change isn't going to rise. It's going to continue. No matter what we do at this point, it's going to rise more. Enough that a lot of coastal places are going to be flooded much more frequently. So if we don't invest in mitigation, we're really going to get swamped by these events, by these processes to do with climate change. So it's kind of, maybe it's obvious, but they actually did it and it really helped them. I was just talking to a longtime colleague of mine who's in Peru. He started working on a project with me in 1989 when he was 19 years old, and he's been on most of my projects since. We brought him in. We're studying a document about the event that took place in 1578, the first big El Nino during the Spanish colonies. It's wonderful for us document because the native lords complained to the authorities in Lima about how they were being forced to rebuild the main canal and to still pay tribute when they were completely devastated and they needed to reconstruct their own food source. So they set up an inspector who had a questionnaire and asked all these questions. About half of the answers are left, and they're very detailed answers by multiple people in the same different, there are lots of villages, but like 4 or 5 in each village. So you can get all sorts of great data out of this. And one of my grad students is working, actually 2 of them now are working on it. Elizabeth Bear's one of them. They're going to be going down there this summer to see something in the field. We brought in this colleague and friend of mine who lives in the biggest valley that on the far north coast that gets really devastated by these El Nino events. I started talking to him. He said, oh, yeah, well, during these events, because he's been through 82, 83, 97, 98, 2017. So, yeah, well, the farmers, they go up to the Middle Valley. They have these fields they can only use during El Nino. So it's not just something that happened between 2,000 years ago and 1,500 years ago that the archaeologists who published recently studied. Apparently, it's still happening today. So some of them are still doing these mitigations. And we want to go take a look at that. Which is pretty interesting, see how much infrastructure they built, how these fields work. Another thing we discovered the last time we were there, right before COVID, was that in a site that's at least 3,600 years old, probably at the beginning older, they're at the base of a hill that can only have water coming down to it during El Nino events, but then they had some gullies that led into the site that get debris flows that are very destructive. Towards the end of the site's history, they built big check dams at the base of the gullies, which are still in place, and they've been only partly breached, and they have protected the surface of this site for 3,600 years. And so one of my other former grad students, who's a Peruvian archaeologist, actually Peruvian, just put in for a grant so we can go study these in detail, figure out how they did it. They did this when they had no draft animals. They just basically, they had no pottery at that point. They basically did this by hand. This is something people could continue to do today. We know a few later examples as well, so people kept doing this, but nobody's paid attention to it before. And this is a very simple but effective technology. We can show that this is the, what we found in the earliest examples. 3,600 years has protected the site by building these things. They're maybe this high, but much wider, a fair bulk of material to hold back, and it's got this giant amount of material backed up behind it. So there are specific things we can learn, and then there are the general lesson that you want to get through these things, mitigate now, because once the events start happening, it's going to be too late. Once we're flooded, right? Thank you. Good question. You got to watch out, because the questions sort of get me off on these tangents, and probably more than you wanted to know. That's an occupational hazard if you're a professor. Give me an audience and then try to stop me.
I have another question about the geography and the rainfall. Like in the northwest, to get the cool, wet air coming in and then dropping right away. And so you don't have the desert there, but then you have the desert behind the mountains. But you don't have a desert. You have a desert right near the shore. Yeah.
I think it's partly the relative temperatures, and it's partly that you get nothing coming from the other side because of the high Andes. So you sort of got the double whammy.
Yeah.
But what you do get, so it doesn't rain, but you get very dense fog in the winter. I mean, the Peruvians will tell you it doesn't rain except during winter. Sometimes I would call that like a light rain.
And that fog doesn't.
But it doesn't. A little, you get a little bit of, and when it's really bad, it'll drop. The surface will be wet. There's almost never enough for anything to flow or to sink into the surface. But one of the interesting parts of this fascinating desert is that between about 200 and maybe 900 meters above sea level, where the fog is thickest in the winter, set of plant communities called lomas communities that are specific. They're xerophytic. They're fog-based dryland vegetation that grow and flourish in the winters. And then during El Nino events, they go wild and they just extend. It's the same plants, but then they grow a whole lot more. But they do grow on the fog. They're able to take the water out of the fog, and then they can probably, I believe they act sort of as natural fog rooms, and they will put some water into the soil there. And there is some soil development where these loma stands occur. They have to be on the right aspect, facing the ocean in the right way, and so on, the opposite side. But you can see them traveling along the coast. All of a sudden, these hillsides are green, where it's normally just barren the rest of the year. So that's the closest we have to that, but it doesn't normally actually precipitate in what we would think of as a real rainfall that would accumulate and start running in rivulets and so on, except during El Nino. I've been through both. Although I've been in El Nino years, I've managed to not get totally rained on. One of my colleagues was there, and one of my Peruvian colleagues was there in 2017 in one of the coastal villages, and he took a video when because it'll accumulate, and then it'll get, the small streams come to the bigger and bigger and bigger, and then you have this giant. He was down by the coast, and it was a dangerous roaring torrent, and he stood near it and took a video, which is kind of scary. But that village only got hit once in that event, but the big city of Trujillo, which was near there, got hit 7 or 8 times, and there's huge destruction from these things. There's nothing to hold them back because there's no vegetation other than right in the flats where they're irrigating. But on the hillsides, there's nothing down close to the coast. And that doesn't happen within the fall.
I have a question.
Yeah.
I can't remember the technical names for the different shells, but you showed some examples of how the red shell was honored in the pottery and some other instances. What are some of the ways that the other shell that's not the fancy big red one showed up? Did that also get incorporated into pottery and artwork?
I only know one pottery vessel that reproduces that shell, because by the time shortly after people started making pottery, so in Peru, they start making pottery about 3,600 years ago. And Then the El Nino change happens like 700 years later, and then they're not present on the north coast, where a lot of the more figurative pottery, the more recognizable pottery comes from. But there is one. I should have thought that I have a picture of it, not here. I should have put it in next time I do this. But mostly not. They're not. The fancy pottery was really for the elite burials and elite use, and they were focused on the spondylus shell, the red one, and the tromettle was the purple one. That was really, it went from being sort of, when there weren't major classes, being an important offering, to being one that was really associated based on the other things found in the burials of people who were of lower socioeconomic status. We don't do that so much. We don't do we? I think we bury people with stuff. The way ancient people did.
Donuts.
Donuts. We bury people with donuts. I like that idea.
Our
You gotta have
grandson,
something for the next.
our
one.
grandson threw donuts into his grandfather's.
My goodness, that's pretty cool. Because food is one of the things you find in burials all the time. You find pots full of food. You find offerings
Oh,
laid out.
golf balls too.
What's that?
Golf balls too.
Golf balls. You get any, you know about the lobster shell golf balls? One of the professors in mechanical engineering at the University of Maine, or no, chemical engineering, had created about 7 or 8 years ago golf balls made out of ground up lobster shell, which everybody throws out, right?
Yeah.
And then you couldn't play competition golf with them, but they're great apparently for practice. And if you wanted to, like you're on a cruise ship and you want, they're going to biodegrade. And they have little lobsters on them, you know, little red lobster with it. I don't know what happened with that. I got to ask them. I haven't seen them for a while. If they were trying to commercialize them. You know, you're using a waste product that isn't going to hurt the environment because it comes from the environment. It's biodegradable, kind of cool idea. So those would be a good kind of golf ball.
Yeah.
But we do have, of course, different kinds of gravestones, different kinds of tombs that tend to be associated with status because they cost money.
What period of time did mother of pearl come into being?
Don't really see that in Peru so much. And they didn't have a lot of nacre shells there. Oysters only show up in one area for one brief time. I showed you this place. I said they had all these warm water shells that normally don't find. That included oysters. Bizarrely, they're warm water. Oh, and you don't find any other oysters. The other thing we found at that site, which nobody's ever found in Peru before, were pearls. Probably they were collecting, and they weren't like perfectly round ones, but they were definitely pearls. I didn't put a picture of that in. I should have thought of that. I have a photo of those. Oh. But that's very unusual. Most of the shells don't have material that would have made good mother of pearl in Peru. And I'm sure they came in prehistory also, but I don't know. Well,
Great.
thank you all very much. This was fun.
Thank
For me
you.
at least.